Hey folks, this is going to be a video that introduces the sine and the cosine graphs. So let's just go ahead and jump right on in. Sine and cosine graphs are going to be called periodic functions because they repeat themselves. So I want you to have your unit circle out. How far around the circle do you have to go before your sine values start repeating? Now remember, the sine values are going to be the y values of the coordinates on your unit circle. So how far do you have to go around the circle before they start repeating themselves? You should have said 2 pi. How far do you have to go around the circle before the cosine values start to repeat themselves? And once again, you should have said 2 pi. Since the circumference, we've talked about this before, the circumference of the unit circle is 2 pi, so the least value for which sine and cosine functions repeat is going to be 2 pi, and therefore those functions have a period of 2 pi. Now, all period means is that that's how far they have to go before they start repeating. For every positive integer, sine of x is going to be the exact same thing as the sine of x plus, I like to say 2 pi n. The author says n times 2 pi. In English, folks, all this means is that I'm taking my x, whatever my angle is, and I'm adding whole circles to it. Maybe 1 whole circle, 2 whole circles, 3 whole circles, etc. And I notice here that this should have said x. The cosine of x is going to also be the same thing as the cosine of x plus a certain number of whole circles. The English version of this, every single time I go around the circle again, I end up with the same cosine value or with the same sine value, just as long as I go whole circles. And I notice here that I did forget to unhide that one. So these are periodic functions. All right, so now I want you to take a look here at your unit circle again. And I want you to only look from 0 to pi over 2. I want you to see what are my sine values doing between 0 and pi over 2. You should have said that they're increasing from 0 to 1, from 0 to pi over 2. Now let's go over to second quadrant. What are the sine values doing in the second quadrant? Again, these are only the y values. So they are decreasing from 1 to 0. In the third quadrant, they're decreasing from 0 to negative 1. And in the fourth quadrant, they are increasing from negative 1 to 0. Now let's do the exact same thing with cosine. This time, though, you're going to be focusing on only the x values. So you're looking at your unit circle, only the x values. What are the x values doing in the first quadrant? They're decreasing from 1 to 0. In the second quadrant, they're decreasing from 0 to negative 1. In the third quadrant, they're increasing from negative 1 to 0. And in the last quadrant, they're going to be increasing from 0 to 1. So a reflection question here. Where does the graph of the sine have a maximum value? And that's going to occur at the value of 1. And it happens at the position pi over 2. Where does it have a low point? Well, that's going to occur at negative 1. And that happens at 3 pi over 2. All right, let's go ahead then and let's graph the parent function of sine. Now, for now, I'm going to leave domain and range alone. I'm not going to fill those in. I will wait until after we've graphed. It's a little easier once you've graphed. So once again, you have your unit circle out in front of you. If I'm looking at just my y values because I want the sine value, what is the sine value at 0? Well, you should have said it's 0. What's the sine value at pi over 6? It's going to be 1/2. At pi over 2, it's going to be root 2 over 2. Now, we're going to be graphing this, so I went ahead and gave the decimal for that, which is 0.7, approximately. Up at pi over 3, my sine value is going to be root 3 over 2. Decimal value there as well. At pi over 2, my sine value is 1. And then we skipped a little bit. We jumped all the way over to pi. My sine value at pi is 0. My sine value at 3 pi over 2 is negative 1, and my sine value at 2 pi is 0. So now what we're going to do is we're just going to take our positions, these guys right up here, these are our positions, and we're going to put those, we're going to stretch those out on the x-axis. So what I did, and you notice here that I've got 4 of these marked over here on the right side, go all the way to the end. This one's going to be 2 pi. And ask yourself, well, what's half of 2 pi? So that's going to be pi. Ask yourself again, what's half of pi over pi? And that's going to be pi over 2. Almost gave it away there. And then what I like to do is I just like to count. So we have 1 half, 2 halves, 3 halves comes next, and then 4 halves reduces to 2 pi. So this is going to give me my main values. Now, I have a few more to graph. I haven't put these guys on my x-axis here, so let's go ahead and try to fit those in. So once again, if you take half of a half, you're going to get pi over 4. And then according to what you know about the unit circle, pi over 6 is going to come before pi over 4. Pi over 3 comes after pi over 4. All right, so now let's put these coordinates on my x and y axis here. So at the x value of 0, my y value is 0. So that's going to be at the origin. At the x value of pi over 6, my y value is going to be 1 half. Now you'll notice that I've marked a value of 1 here at 3 blocks and -1 down 3 blocks. So at pi over 6, if I'm going to go up to a half, I'm just going to go up a block and a half. At pi over 4, I'm going to go up 0.7. Pi over 3, I'm going to go up 0.87, almost 0.88. And at pi over 2, I'm going to go all the way up to 1. And then what I have is I've skipped some quadrants here. So at pi, I have a height of 0. At 3 pi over 2, I have a height of -1. And at 2 pi, I have a height of 0. Again, an x-intercept. Now what you have here is it's going to end up being a wave. Here is kind of the first curve of that wave. And then we're going to have a mirror image of it going to pi. And then we're going to have a very similar wave down to 3 pi over 2, -1 there, and finish that up at 2 pi. Okay, now at this point, it's pretty easy to get the range of this. You'll notice that the high point is 1, the low point is -1. So the range of my graph is going to be -1 to 1. And you'll remember we in a previous section, I gave you the ranges, and in class I told you you're not going to understand these ranges, but once we graph them, it'll make a little bit more sense. My domain is going to be all real numbers, and the reason for that is because I can keep getting y values if I go around and around and around and around the unit circle. And so this particular graph is just simply going to keep repeating itself. Now remember we talked about the word period. What I have here in purple is the original period, we would say, of the parent sine graph. In the red, that's just another period. So I have 2 whole periods drawn on this particular graph. Notice that the x-intercepts occur here at the origin, and then they occur pi later and 2 pi after that. So my x-intercepts occur, they start at 0, and then they occur every whole pi after that. The period, once again, we've already talked about this, is 2 pi because it doesn't start repeating itself until it has gone through a full cycle of 2 pi. Now, what we have down here is I've just given you a calculator version as well as just simply another sine graph that's drawn for you. All right, now let's take a look at the cosine graph. The graph of cosine is really going to be the graph of sine shifted, and it ends up being shifted pi over 2 units. I'll show you that here in just a moment. But first, let's go ahead and get some values. And you'll notice here that I've got some of them filled in. Quite frankly, I did not fill in these 3 right here. Because since we're being told that the cosine function is simply the sine function shifted, I already kind of know what the shape of this is going to be. So I just didn't fill in all those y values. So once again, let's go all the way out to the last one, and that's going to be at 2 pi. Take half of that, you'll get pi. Half of that, you'll get pi over 2. And then if you count, you have 1/2, 2/2, 3/2, 4/2. All right, so at the x value of 0, we're going to graph the y value of 1. And then go ahead and jump all the way down over here. At the x value of pi over 2, we're going to graph a y value of 0. At pi, we're graphing a y value of -1. At 3 pi over 2, we're graphing 0. And at 2 pi, we're back up to 1. And so what you have for the cosine parent is something like this. And once again, I think you can see here that I'm just simply shifting my my sine parent. So I'm going to do this. This is going to mess things up a little bit. So just watch, but I'll fix it here in a minute. If I shift this whole entire graph pi over 2, you'll see here that actually this is my sine function. Remember, my sine function started at the origin. Oh, I'm sorry, I shifted the wrong direction. Let's try that again. If I shift it to the right pi over 2 and I finish it out, you should be able to see there my sine function. All right, let me put that cosine back where it belongs, but it is just simply the sine and the cosine function are the same thing. They're just shifted. Domain and range here. Again, my domain is going to be all real numbers because it can keep going, and my range is going to be -1 to +1. My x-intercepts, notice that my x-intercepts this time start at pi over 2, and then they occur every pi after that. So pi over 2 plus a whole pi lands me at 3 pi over 2. If I add another whole pi, it'll land me at the next x-intercept. The period, once again, is 2 pi. And here is, again, just 2 more graphs that have been given to you. One on the calculator and one on just a regular graph. All right, I'm going to stop the video here, and I'll come back and do some examples.